In the previous class we have discussed about, just we have started this relations. Relation. Okay, so what is the relation? Relation is a subset of Cartesian product. Suppose we have A and B, A Cartesian product. Suppose A and suppose A and B are the two non-empty sets. Okay, A and B are the two non-empty sets. So then the Cartesian product is A cross B, and this is a set AB such that A belongs to A and B belongs to B. Okay, and what is the relation? Relation is the subset of A cross B. Is it clear? This is the subset of A. So ultimately, it is ordered here. Okay. Sometimes we are taking the actually practically when we are using the or when we have studied the database. Okay. So in database we have more than two sets, like suppose your name, your roll numbers. Okay. What is your CGPA? Then what are the minors you have taken? What are the majors you have taken? These are the various sets. Okay, and there we need to combine one with other. There we need the n array relation. It is the ordered pair relation. So it is a special case of the n array relations. In computer science, basically we use the n array relations. N array relations, that means we have more than two sets. Okay, actually these are other two tuple n tuples relations n tuples. That means we have suppose like this a1, a2 up to an. Okay, so remember actually this is the subset of some r and it is denoted by the r in whatever maybe. Okay, this is denoted by r squared, but right now we are using simply r. Okay, so leave these terms. So R is a subset from subset of the element from A plus B. Okay, and previous class we have discussed this one. And important thing is a relation from it is a relation from A to B, or you may write it like this: A is R related to B. Okay, but the important is the relation from uh, like this: AB, A, B both belongs to A. That means relation from A to A. Relation from A to A. So actually it is said to be relations defined on a non-empty set A. This is the relation defined on non-empty set and this is very important. Okay. Now based on this, that means R is a subset from R is a subset of A cross A. This is very important. Now based on this definitions, we are going to classify the relation. Okay. So tell me what are the differences. You have already read this in class 11. So I am asking you, what are the different types of relations? Classification of relations. Not only, what are the classifications?
Reflexive, symmetric, transitive.
And any other?
Equivalent.
Equivalence. So equivalence is different thing. And one word is antisymmetry. Okay. The first one to the reflexive. Reflexive relation. So what is the reflexive relations? So how to define this? We let R be any set, any relation. This will not write any R relation is defined on A. Okay, then R is said to be reflexive. If okay, A is R related to A, and here we use the quantifier for all, universal quantifier for all A belongs to A. Okay, A is R related to A, and this is very important for all. Okay, here we use the universal quantifier for all A belongs to A. Then it is said to be reflexive. For example, and okay, later we come to the examples. Second, next one is symmetry. Symmetric relation. So, what is the symmetric relations? Can anyone define?
The A belong to B and B belong to A, that one.
Yes. So how you define that?
For every relation AB, there exists a relation BA.
There exist. Okay. So here also we use the another quantifier. There exist. So how to define this? Same thing. Let R be same things. Let R be on A. Same line. Okay. Then R is said to be symmetric. Symmetry. If then R is called symmetry if A is R related to B, then B is R related to A, or AB belongs to A. If A is R related to B, then B must R related to A. Or you may write it over this. Is it clear? Or so that is, you may write in this one. No. R symmetry if A is R related to B implies B must be R related to A for AB belongs to A in A. Okay, it is. So what is the meaning of this? A is R related to B, then B must be R related to A. And in many books, in fact, in the book of the Kenneth Rosen also, okay, there also it is written for all like this, for all A B must. It is written, but it is not true. Okay, for all R related to B, it may happen, but not for all A B. Okay. Here, for all A must be R related to A, then we say that it is a reflexive. But in case of the symmetric, if A related to B, then B related to A. If there doesn't exist any such relations, no problem. In that case also it is symmetric. Is it clear? So
Yes,
don't
sir.
confuse with the other
Yes,
one.
sir.
In many book it is written for all AB. For all AB belongs to A, but it is not true. Not for all AB. If A related to B, then there must exist B related to A. Then we say that it is symmetry, but not necessarily for all AB. Okay.
Yes.
So the third one is transitive. Okay. So before this antisymmetry, you see antisymmetry. Antisymmetry relation. So what is the antisymmetric relations? A relation, it is important. A relation over a set is called, this is the, it's called antisymmetry. So for all for all AB belongs to A. If say suppose I'm writing like this, if AB belongs to R and A is not equal to B, that is not reflexive, then BA does not belongs to. So it is the one definition. A relation R on a set A is called antisymmetric if for all AB. For all AB, that means for all AB, that means the AB which belongs to this R, not for all AB belongs to A. For all AB, if AB belongs to R, in another word, you can say, in other word, you can say if A is R related to B and B is R related to A, okay, this implies A must be B, okay, then symmetry. If A is R related to B and B is R related to A, then A must be equal to B, otherwise it is symmetry. And in another way it is written, it is said to be antisymmetric if AB belongs to R and A is not equal to B, then this this does not belongs to. This does not belongs to R. So what I am writing here, if this and this both exist, then this A is equal to B. In another way, you can write if AB belongs to R and AB is not belongs to R, then BA does not belongs to R. So I think this is the, in many books this definition is given. Okay, but this definition is, as per my opinion, this is better definition. Okay. And transitive. Later I come to the examples also. Transitive. transitive relation. So what is the transitive relation? If A belongs to A, A, B, and C, these three belongs to A. Okay, then a relation R is called transitive. If on A, if A is R related to B and B is R related to A, this C, then A must be R related to C if such conditions arise. Okay, that means here we can use the connector this also, A and B, that means this and this, then must A is R related to B, B is R related to C, then A must R related to C. You see, relation is ultimately a set of not a single number, it is a set of n tuples. It is a set of n tuples, ordered pair, ordered triplet, or n tuples. But since it is a set, then definitely all the properties of the set must holds for these relations along with some other properties also. But whatever the property of the sets we have, they are also applicable to the relations also. Okay, in the set also we have the transitive relations. This. Now come to some example. And one more thing, suppose any relations, broadly I'm saying that equivalence relations. Equivalence relation. So what is the equivalence relations? R is said to be equivalence relation. R is said to be equivalence relation. Where? On non-empty set.
Reflexive, symmetric, and transitive.
Good. Non-empty set A, if it is, first one is reflexive, second is symmetric, and third is transitive. Okay, and can anyone know what is the partially ordered set? This is very important thing. R is called partially ordered not set relation. Partially ordered relation if, any idea? आप पढ़े हो क्या कुछ partially ordered relation like this?
No, sir.
No, sir. No, sir.
So the partially
No,
ordered
sir.
relations, that means reflexive, second is anti-symmetry. Okay, anti-symmetric, and third year is transitive. Okay, symmetrics, equivalence relations, partially ordered relations, anti-symmetry. Okay, so how can you show that? Actually, this is very important. This is very important because you see when you are writing the that means in the database, DBMS, database management systems, always we encounter with the ordered relations. Ordered relations, that means whether 2 is less than 3 or 3 is less than 2, like this. Okay. So always, if you are dealing with some real number problems, then definitely orders must preserve their order. That means there are 5 orders: equal to, less than, equal to, and the first is equal, third less than, second less than, third greater than, fourth one is less than equal to, and fifth one is greater than equal to. So we have a 5 ordered relations. Okay. And some in a particular set, all the ordered relations are not defined. All are relations, 5 relations are there. Some relations, when you define in a particular set, that give you equivalence relations, or some give you the partially ordered relations. Okay. Some may not give both of these, but some give you some only reflexive or only transitive, these things. Okay. Now come to some example. Take the very simple example. Simple example I'm taking here. Okay. Suppose I'm considering the set R. Okay. R is 1, 1. Before that, I'm considering a set first. Okay. So take the finite set 1, 2, 3. Okay. And now find the relation R1. Okay. And this relation is 1, 1, 2, 2. You may take 3, 3. You may take 1, 3 and 1, 2. Okay. Second relations you may take like this. 1, 1, 2, 2 and 3, 3. Okay. Next take 1, 2, 2, 1, 2, 3 and 3, 2. I'm taking this one. And another is suppose 1, 1, 2, 2, 1, 3 and 3, 1. I'm taking these 3, suppose. Now tell me, what about the R1? These 3, suppose I'm considering reflexive, symmetric, and transitive. And this is R1, R2 and R3. Okay. So which one is first one? Now everybody just see what is the answer. What about this R1?
The R1 is reflexive.
Reflexive, because you see,
Yes, sir.
only reflexive means
1, 1, 2, 2, 3, 3 is
reflexive
present.
means AA must belongs to R, and it is for all A. So 1, 2, 3. So 1, 1, 2, 2, 3, 3 all are present. So it is reflexive. Symmetric, that means if 1, 3 and 3, 3. You see 1, 3. If 1, 3 is there, then is 3, 1 is here? No.
No,
So it is
No,
not
sir.
symmetric. Transitive.
yes, sir.
No, sir.
3, 3 is here. Okay.
So 1, 3 is not here.
If there is 1, 2, 1, 1.
Oh, yes, yes.
So it is transitive.
Transitive it will be, sir.
You see,
So it will be
1, 1,
transitive.
1, 1, 1, 1. Okay. This one and this one. Okay. So 1, 3 is exist here. Next is, it is again 1 here. So 1. Last entry is 1. Here first entry is 1. So this one and this was 2. So exactly 1t is also exist here. So it is the transitive. Okay. Next.
Reflexive, sir. Reflexive and symmetric, sir.
Second one is R2. R2 is what?
Reflexive
Or
and
reflexive
symmetric.
and
Reflexive
symmetric.
R2, this all. Okay, it is reflexive. Then
Reflexive
the
and
symmetry.
Symmetric, sir.
Symmetric, how it is symmetric? 1 2 is there, then 2 1 is also here. 2 3 is here, then 3 2 is also here. 3 3 is here, then again 3 3 is here. That means it is symmetric. Whatever transitive 1 2 2 1 1 1 is here. 2 3 2 2 is also here.
It is
Then, is it transitive?
Equivalent, sir.
Is it transitive?
yes, sir.
in R2 now.
Sir, you are marking on
Marking
R3 row.
Sir, R3.
Oh, sorry, 3. Sorry, this one. This two, no. What about this? Oh, sorry. Is it transitive? Two, two, two,
Yes,
three.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Just a minute. 1 1 2 2 1 1 1. Three.
No, sir, it's not.
For 2 3 it is not.
Sir, 1 3 is not there.
Sir, for 3 2 and 2 1 3 1 doesn't exist, sir.
1 3.
Sir,
Sir,
1
3 1 is not there.
3 1 is not here, but 1 3. It is where it is 3 3. So 3 2 is here. 1 1 1 2 1 1 2 3 2 2 3 1 2. You see here this one and this one. One is related to 2 and 2 is related to 3. Is 1 is related to 3? Is it?
No, sir.
So it is not positive. Okay.
Yes, sir.
Third one
Yes,
is
sir.
third one.
Not reflexive.
Is it
It is
reflexive?
not
Is
reflexive,
it
sir.
reflexive?
No, sir.
No,
Then
sir.
symmetric 1 3 3 1. It
No.
is
Yes, sir.
symmetric. And transitive it is 1 3 1 3. It's okay.
Yes, sir.
Okay. 2 2
Yes, sir,
3
it
is
is
not.
positive.
Sir, but 2 3
So
is not.
2 3 is not.
So only symmetric, no?
not
2 3 is not present.
it is 2 3.
Sir,
So
2 3.
2 2. No, it is transitive.
How?
2
Yes, sir,
3.
it is transitive.
Yes, sir. It's transitive.
Yes, sir, it
Why
is
you are getting
transitive.
the 2 3? Why you are getting 2 3? No, it is transitive.
Yes, sir.
Okay. So we are getting this one. Now suppose I am writing the another example. So is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
And
Yes, sir.
suppose another example I am taking. Suppose example I am taking the any number. Okay. Suppose a is equal to a is 1 2 3. Okay. And R is the relations. Suppose I'm taking 1 1 Okay, then 1 2, then 2 1, then down the 2 2, then 2 3, then 1 3, 3 1 again I'm taking, and then 3 2, 3 3. Now it's sufficient. Okay. Now check it. Check it. Check it for reflexivity, symmetric, and transitivity.
Sir, it's reflexive, symmetric, and transitive.
All.
Yes, sir.
You see here 1 1 2 2 and 3 3. So it is reflexive. Okay. Is it? So 1
Yes,
1 2 2 and 3 3. This belongs to R. Okay. So it is reflexive. Next, you see if A 1 1, so okay, leave it. So 1 2, then 2 1 is there. Okay. 2 3, then 3 2 is here. 1 3, then 3 1 is here. Okay. So it is symmetric also. Okay. So A is related to B. If A is related to B, then B is related to A. So it is symmetric. And transitive, 1 2 is here. 1 2 is here. Leave it. 2 1 1 1 is here. Okay. 1 2 is here. 1 3 is here. Take only first you take this one and check whose first entry is 1 over here. This is 1. So 1 2 is here. Okay. Next anybody 1 1. So 1 3 is here. So leave it 1 2. So 2 2, that means 1 1 is here. Then 1 2 is here. Then 1 3 is here. Next leave it. Come to here. So 1 leave it. 2 leave it. Come to the 3. So 3 3 3. So is 2 1 is here? Yes. Next 2 2 is here and 2 3 is here. 2 3 itself. So leave it. Okay. That means A is R related to B and B is R related to C. This implies A is R related to C. It is the transitive. Transitive. So is it equivalence relation or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, so
So therefore R is an equivalence. Equivalence relation. Okay. Similarly, we have the other reasons. Suppose set of the similar triangle. What about this? Set of the similar triangle.
Equivalence.
Is it equivalence? Okay. You see, congruent
yes,
triangles are similar. Congruent triangles are similar, so it is reflexive. Okay. Second, if one triangle is
Similar to other, then definitely the reverse also exists. So and third, it is equivalence relations. And example, so firstly, a set of similar triangle are the set of similar triangles. Okay, set of similar triangles, and it is a and here if you define the relation, that relation is equivalence. Next, suppose I'm considering a set of integers. Okay, and set of integers is basically denoted by z. Z includes positive, negative, 0, all. Okay, just a minute. So set of integers is z, and we defined A is R related to B. Okay, if A minus B is an even integer. Suppose this is your relations. Now tell me whether R is a equivalence relations, yes or no. This is the set of integers including plus, minus, 0, all. So you see here A is R related to A. This implies A minus A, that is 0. Okay, which is divisible by 2. Okay,
Yes,
is
sir.
even. You can write it like so. R is reflexive. Okay, second, A is R related to B. This implies A minus B is given. Okay, so this implies minus A B minus A, or you may write it like the A minus B is even, then B minus A, even integers, or this can be written as evens. So now B minus A, this is equal to minus A minus B, which is
Even, sir.
which is an even integer. So therefore you may write A is R related to B implies B is R related to, and this is for all AB belongs to Z.
A. Z.
Belongs to Z, and here also you should write for all A belongs to Z. Here it is not required written, but in this case for all AB it is possible. So leave it, don't write this one. So it is symmetric. Okay, transitive. Transitive means A is R related to B implies what? A is R related to B means A minus B is an
Even integer.
So this implies A minus B is equal to twice M. M being an integer. A minus B equal to 2M. M belongs to Z, and B's are related to C, again implies B minus C is equal to twice N, suppose, and N belongs to Z. Okay, Now you may write A is R related to C implies what? Or you may write A minus C. This is equal to how much? A equal to how much? Twice M
2n
plus
plus
B.
b, sir.
And this is minus twice
b
N.
plus 2n.
Sorry, B minus 2. Okay, so this is 2 times M plus N. So this is the integer. M plus N is also integer.
Yes, sir.
So therefore, A minus C is an even integer. So what you see here, if A is R related to B and B is R related to B, then A is R related to C. Therefore, A is R related to B and to C. This implies A is R related to C. So it is transitive. Okay?
Yes, sir.
Yes.
R is transitive. And from here you may write R is equivalence. Equivalence relation. Okay. So next class we will show how to represent the relation using the matrix or using the graph. Okay, and we have the other properties of the relations. That means that is the combinations of the relations since it is a set. Okay, so like union of sets or intersection of set or the difference of the sets which are which have in fact practical applications in computer science. That are the union of relations, intersection of relations, so the difference of the relations. We will study that one in the next class, and one more how to represent the sets using the graph or the matrix. Okay, actually the problems arise for this transitivity. Okay, so we need the proper algorithm for this transitive to check whether the relation is the transitive or not. Reflexive and symmetric, it is not so tough. Okay. So
Yes,
next class is and when you will give the test of module 1 and 2, tomorrow you will give the test.
No, sir, I'm talking about
I'm
class.
asking
No, sir.
about the test of module 1, quiz of module 1. So in this week, because in the coming Monday probably again we have some holidays. So in this week you just fix a time, fix a day. Time is from 5:30. Okay, fix a day.
Okay, sir.
Thursday,
Okay, sir.
Friday, any time, but time is from 5:30 to 6 o'clock. Okay.
Okay, sir. Will inform you.
So module 2 or module 1?
Okay, sir.
Okay. Module, you just specify whether you will first give you module 2 or module 3, and next class you inform me. Okay.
Sure, sir. Sure.
So let me take. Okay. Okay. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.